Now that we've looked at volume and surface area of 3D figures, we're going to start finding volume and surface area of composite figures. So these are figures that are made up of two or more of our 3D shapes. We're going to start with finding the volume of composite figures, and when we do that, we're just breaking it into its smaller shapes that we have on our formula sheet, and we'll find the volume separately, and then we'll end up adding those volumes together. So for this first shape here, we have a bigger box in the back, and with our big box, we're just finding the volume by doing the length times the width times the height. We find the length by looking across our length down below. I see that this little piece is 2, this piece is 4, and this other piece is 2, which means this entire thing is 8. And we get the volume of the big box to be 336. Then we're going to find the volume of the little box, which is this box out front here, and our dimensions for that are 4, 2, and 4. That volume is 32, so to find our total volume, what we're going to do is we're going to add those volumes together, and we find that the total volume is 368 feet cubed. Remember, volume has a measurement with cube. The next example that we're going to look at has a box and it has a pyramid up top. So we're going to find both volumes. We're going to start off with that box again. We're just doing length times width times height. Then for our pyramid, we are going to have to find big B for our formula. So that's the area of the base. They told me that one side is 9 and one side is 4. Since that bottom is a rectangle, the area is just length times the width. So I'm going to use big B as 36 in my formula. 10 is the height inside our pyramid, and then we're multiplying by 1/3. Since we're finding the volume of the entire shape, we're going to add those two volumes together, and we find that our final volume is 1,296 inches cubed. Our third shape that we're looking at is this sort of L shape, and you can see that I drew in a line to sort of visualize our two different shapes. If you wanted to, you could have split it across horizontally too. In the end, you'll get the same volume. So when I did it, I first started with our horizontal box, so that's this box over here, and we're using 4, 2, and that volume gives us 16. And then we're doing the vertical box, and so for the vertical box, we have 2 by 2 by 4, and that's also 16. So when I add those together, I get that my total volume is 32 inches cubed. Our last shape is this sort of house-looking thing down here. We have a box at the bottom, and we have a triangular prism up top. So we're going to start off with that box. For me, those are the easiest to start off with. We're going to find our volume of the box, and then we're going to focus on the volume of our prism. Remember, for a triangular prism, in our formula, when we're talking about big B, we're talking about the triangle. We're finding the area of that triangle. For the base of my triangle, it's the same as my length down here, so that's 13. My height for the triangle, just the triangle, is 12, and I multiply by 1/2. And then when we go to our formula, remember that height in our formula is talking about the distance between our triangles, and that distance is 27. So we're multiplying there. And then for our total volume, we're adding those two together, and we get our final volume is 4,914 centimeters cubed. So all of that was for volume. Volume is pretty simple. We're just doing each piece. Surface area is where it gets a little bit trickier. We're looking at those same shapes that we did volume for, but now we're looking for the surface area. When it comes to surface area, it's a little bit harder because we can't do the surface area of one plus the surface area of the second. Because if we look right here with this face of the bigger box is also touching one of my sides of my little box. So we're taking out a part of that bigger area, and we're not counting that side on our little area. So it just makes things a little bit more difficult. We're going to do this by separating it out again, and we're going to do a little bit of visualization. So starting with our big box, our surface area formula is 2 times the length and width plus 2 times the width and height plus 2 times the length and height. And you can do that in any order. And I'm finding the whole big surface area of this box. That gives me the top and the bottom and all 4 sides. We're going to deal with that overlapping part in a second, but we're going to next find the surface area of the little box. So for the little box, we're using that same formula, but the only difference is that one of our sides we're only counting once. So the side here that's 4 by 4, I'm not counting the side that's touching my other box because it's not going to be covered. If we were covering this with wrapping paper, I don't go inside something. I'm just doing the outside. So we're only counting that side once, but the other 2, we're still doing 2 of those sides. And then the last piece that we have to take care of is our overlapping section. So already, when I found my big box surface area, I did count the piece that's hidden behind this little box. So in order to take care of that, I'm going to find the area of that shape. That shape gives me a rectangle or a square. So I'm just doing 4 times 4, and just right underneath my box is 16. For my total surface area, what we're going to do is we are going to end up adding the 2 areas together, and then we're going to subtract the overlapping part. And that'll give us just the outside of all of our shapes. So when we look at that, it's 292 plus 48, our 2 surface areas for the boxes, minus our overlapped piece of 16 to get 324. And 324 is measured in feet squared. So surface area is squared, volume is cubed. The next shape that we're going to look at is that box with a pyramid on top. Again, we're going to do our 2 separate surface areas, and then we'll see if there's any overlap that we need to take care of. Starting with that box, we're just finding the normal surface area. We're just going to do all of the sides. And when we do that, we get 700 as our surface area for just the box. Now that is including the piece underneath my pyramid, so we will have to take care of an overlap section. So why don't we do that next? The overlap section is the piece that the pyramid is touching, and the base of the pyramid is 9 by 14. So when I find that area, I get 36. So I know I'm going to have to take away 36 from 700. And I also need to end up adding whatever the area is, the surface area is for our pyramid. Since we don't want to count the base of our pyramid, since we just want the sides, we can use our formula on our formula sheet that says LA. LA stands for our lateral area, and that's just giving me the sides around. It doesn't include my base. So for that, we're using our slant height, which is L, and in this case, that's my 11. They marked it for us. Slant height is on the outside of a pyramid, and height is on the inside. And then P is perimeter of our base, so I'm doing 9 plus 4 plus 9 plus 4, doing that whole rectangle. And that gets me my lateral area, which gives me the sides of my pyramid, as 143. What we're going to do now is we're going to add those surface area and lateral area together and subtract that overlapped part that we counted with our box. And that gives us 807 inches squared for our total surface area. 2 more examples to look at. For the next one, we have that box again. You can see I split it up in a different way this time than I did for our volume. Again, if you wanted to go straight down, you would still get the same surface area. For this one, I'm showing you that you can do each side individually and just find the area of that 2D shape. So it looks like a lot, but if you just sort of go around and count all of your sides, you'll get it all. So one side is a 2 by 2, and then we have the base as a 6 by 2. We have our right side as a 2 by 4. We have our top piece as a 2 by 2. We have this side piece of the L as a 2 by 2. And then we have this length here as a 4 by 2. So that just sort of gave us our round, and then we have to count the front and the back. The front, the way I split up the shape, gives me a longer rectangle that's a 6 by 2, and it gives me a baby square that's a 2 by 2. I have that mirrored on the other side, so I added another 6 by 2 and 2 by 2. And when you do all of that and you multiply it out and you add them together, you get that the total surface area is 72 inches squared. So it looks like a lot more work, but it's just another way to visualize. You can do it piece by piece if that makes a little more sense to you. Our last example is our house shape. So with this house shape, we're going to start off with the box. When we do the box, remember we're not counting one of our sides, so I'm just doing one of my length times my height. I don't want to count the side that's touching my prism. In order to find my prism, what we're going to do is we are going to add up each piece, sort of like what we did for our previous problem. So my prism is made up of 2 rectangles and 2 triangles. So finding the area of those, I have the formula for 2 rectangles, length times width, and the formula for 2 triangles. So 1/2 base times height. For the rectangles, we have a 13 by 27, and we have 2 of those. And then for the triangle, the height is 12, and then our base is 13. And so we're using 13 for those. And we get that our surface area is 858. Again, that's discluding the last side that's also touching our box. For the total surface area, we're going to add those two numbers together, and we get that the total surface area is 1,849 centimeters squared. So with finding surface area of our composite figures, we just really have to make sure that we're now not counting those overlapped sections. And then for volume, we're just finding the volume of each shape individually and adding them together.